Hello and welcome back. Due to the effect of the collinear forces, we are considering an imaginary section like that. If we cut an imaginary part, the force acting on the section due to the equilibrium of forces is also equal to the B. So if I am acting by B here and B there, this imaginary part due to the equilibrium, if we cut and look from that side, we should have an opposite B in this direction. If we cut and look from outside, we should have a force acted upon in this direction to the right. And we could draw the stress diagram as follows. Since these are uniform, we can assume that this is parallelogram with equal sigma. Stress is called sigma, and if we are going to divide the force by the area, we get what is called stress sigma, where sigma is equal to the P over A. P is the force and A is the cross-sectional area acted upon by the forces. So this is the transverse area acted upon by two forces, and this is direct tension forces. Of course, we could apply other forces, compression in the other opposite direction, but the stress value here will be negative. And the symbol of the stress is sigma, which is Greek letter sigma. The average normal stress distribution, we could say that this is cylindrical shape and it is in the Z direction, and the force acting in the Z direction. And this is a uniform distribution as well. And the delta force due to the effect of the force is equal to the sigma multiplied by the delta E, and then he is going to make, if he is going to take infinitesimal small prism like that, and he is going to make integration, so the force B equal to the sigma E after the integration to the full of L. What about the strain? If we are going to make tests and bringing specimen, and you are going to compress this specimen, or you are going to apply tensile force, due to compression the specimen will get shortened, and due to the tension forces it will become elongated. So the strain is defined as the change in the dimension with respect to the original dimension due to the stress is denoted by epsilon. So the epsilon is the change of the length divided by the original length, which is called, the change of the length is called deformation. When a force is applied to the body, it will change the body shape and size. These changes are deformations. And between two pictures, he is marking the two specimens, and note that before and after position 3 of the line, and he's getting, by using gauge, he is evaluating the amount of deformation. Again, normal strain, the elongation or contraction of a line segment per unit length is referred to as normal strain. Normal because it is normal to the cross-sectional area of the bar or of the cylindrical shape. And if the normal strain is not, then we could evaluate the approximate final strain, final length. The final length, if it is increased, then it will become 1 plus epsilon delta S. If it is decreased, then the sign will be negative. Based on the stress-strain curve, we can plot the following shape, which we explain the next time. Thanks a lot and see you.